Hi everybody, we are getting towards the end of this unit on linear functions, and to finish it off we're going to have a couple lessons on modeling situations with linear functions, which is just kind of a fancy way to say word problems. So let's get into it. So again, these are going to be word problems, and there's a few things to keep in mind as we're working through these. We still are going to need to have a slope and y-intercept to write our equation. But in a word problem, it's not going to say specifically slope. All right, so one term that typically comes up is the rate. If it says the rate, that is your slope. Or the amount that it's changing. All right, and remember that's the same as y minus y over x minus x, but we'll look at some other ways to deal with it. Some other keywords that you'll see if you see the word per. So per week, or per day, or each week, or each year. All right, so if something is changing the same amount, per day, per hour, per week, that is going to be your slope. Your y-intercept is always your initial or starting amount. All right. So let's just get into it. We're going to practice for a couple of days because I know word problems can be tricky. It's important that you read through it a couple of times, underline key information. All right. So Janine has $450 in her savings account at the beginning of the year. So that's her starting amount. That word beginning should be giving you a hint that might be your y-intercept. She places money in the account at a rate of $5. There's that per week. So that's going to probably be your slope. All right, but to help us figure it out, let's take a look at this table. So if no weeks have passed, that means this is going to be your starting amount or your y-intercept. All right, when your x value is 0. All right, so she has $450 in her account. So her total amount is $450. If 1 week passed, she has the $450 plus she gets $5 per week. So 5 times 1 week, she's going to be up to $455. Or you could just type that into your calculator. All right, after 5 weeks, okay, so she has the $450 plus she gets $5 for each week times 5 weeks, that's $25. So now she's up to $475. And again, some of those you can do in your head, but if you just type that in, move this a little, 450 plus 5 times 5, that's all you have to do, 475. All right, and finally, if 10 weeks have passed, she's got the $450 initially, plus $5 times 10 weeks, that's $50, which puts her up to an even $500. All right, so if you notice the pattern, see how it changes each time? This is where our x would typically go. All right, think about this equation. Y equals mx plus b. So w is kind of like your x. The amount you have, or the s, is your y. All right, think about slope and y-intercept. Our slope, it's going up $5 per week plus the starting amount of $450, and that's how you get the amount of money in your savings. So instead of x and y, we're going to use that. All right, so write an equation for the savings. It's capitalized, just like you capitalize the beginning letter of a sentence. So the savings are y equals, which is s equals 5 times the number of weeks plus $450. If it's easier, that got a little messy. If it's easier, start with y equals, so you know your slope is 5x and your y-intercept's $450. And then just replace the y and the x with s and w. If Janine saves for exactly 1 year, What's the range in her savings over the year? All right, so there's a few things going on here. First, let's figure out how much she would have after 1 year. And remember, it's being measured in weeks. There's approximately 52 weeks in a year. That's typically what we'll go with. So I'm going to take my formula, 5 times 52 plus 450. And I'm going to put it right into my calculator so I don't make any mistakes. 5 times 52 plus 450. 710. So in 1 year, she's going to be up to $710. All right, but that's not what it asks. It says, what's the range? So we're going back to functions. Remember, you have x and y. Your range value or your y value is being used. In this case, it's the amount of money. So she started with $450 and she got up to $710. So I'm going to write my range in interval notation. Or you could say, from $450 to $710. All right, I'm going to pause for just a second. Okay, so let's try a couple more of these. Just again, keep in mind your initial value is your y-intercept. How much it's changing per week or per year or per hour is your slope. You put it all together using y equals mx plus b and then substitute in whatever letters you need. All right, so Kirk is driving along a long road at a constant speed. He's driving directly towards Denver. He knows that after 2 hours of driving, he's 272 miles from Denver. After 3.5 hours, he's 176 miles from Denver. Calculate his average rate of change with the given information. Okay, so this one's a little bit different. It wants us to calculate his average rate of change. Remember, another word for that is slope. And you might say, well, how am I supposed to find the slope? I don't have 2 points. Well, you actually do. 2 hours of driving, he's 272 miles. So here's your x and your y. After 3.5, so 3.5 hours, he's 176 miles, getting closer because he's driving towards Denver. So if you want to calculate the slope, you have a couple options. Remember, it's y minus y over x minus x. Notice how I put the x and y above. So you want to subtract how far has he gone? The miles, think about it like this. If you're not sure which one goes on top, it's talking about miles and hours. Think about the speed limit sign. It's miles per hour. Okay, so figure out the difference there. I'm going to do 272 minus the 176. And then how much time passed? I'm going to still go in this order because, again, the slope's going to be negative because he is going towards Denver. All right, and we'll talk about it. So since I did 272 minus 176, I have to do 2 minus 3.5. All right, so we'll subtract those. We get 96 divided by negative 1.5, negative 64, because he's getting closer. So the distance is getting smaller. But if we're talking about what his actual speed is, you don't want to keep the negative on. It'd be 64 miles per hour. Another way that you could have done that is using that calculator shortcut we talked about. So the way I set this up, your x is going L1. So we go stat, enter. Up, clear, down. Up, clear, down. And you can always use this because let's face it, sometimes we forget what we need to do here, right? Maybe we make an error. You can always use your graphing calculator, so why not at least check it? So my hours are 2 and 3.5. My miles, At 2, it was 272, and at 3.5, it was 176. We're still talking about a linear equation. Oops. So we're going to hit Stat, go to Calc, choose choice 4, negative 64. All right. And look what else is there. That's going to come in handy too. I'm going to write that down. Let's kind of write it over here. So when we went to Stat, we got this, and this is perfectly acceptable. So rather than going through all of this, you can use this method. So it was negative 64, and I think it was 400. Let's just double check. Yep, 400. Slope, y-intercept. Assuming the relationship is linear, which this is, write an equation for the distance d as a function of the number of hours h. So again, let's think of our y equals mx plus b. Guess what? We have it right here. Y equals negative 64x plus 400. But they're not using x and y. Distance is d, that's your y value, and it's capitalized just like the beginning of a sentence. And then instead of negative 64 times x, it's negative 64 times the number of hours. And you could have just done this from the beginning and found your slope and not had to go through all that. How far did Kirk start from Denver? Again, your starting point is your y-intercept, 400 miles. Okay? Utilize your graphing calculator. All right, after how many hours will Kirk arrive in Denver? Show the work that leads to your answer. Okay, well, we can do a couple of things. So this is his equation, negative 64 times the number of hours plus 400. We want to know when he's at 0, when he's 0 miles from Denver. So if we subtract 400 from both sides, then we're left with negative 64h equals negative 400. Divide by negative 64. And the hours equals 6.25. But again, all this could have been generated just by using that stat function in your calculator. But if you'd like to do it this way, that's fine. All right. Okay, so we're going to stop there. I would like you to get some practice in on page 31 and 32. I will be putting out a key for this, but again, let's do the first one together to make sure you're comfortable. So Amanda's walking away from a light pole at a constant rate of 4 feet per second. That per tells me that's going to be my slope. If she starts at a distance of 6 feet, again, that word starts, that means that that's your y-intercept. Write her distance, d, from the light pole as a function of time, t. All right, so time goes with slope. All right, so let's think about this. If we knew the slope and y-intercept, it'd be y equals 4x plus 6, right? How fast she's moving, how far she was to begin with. But again, it doesn't want you to write it in that form. It wants you to use your letters. So slope is how fast she's going per second. So the t is your x. The total distance is your y. So just replace those. D equals 4 times t plus 6. So just make sure if you start with the y equals that you then incorporate those letters. Okay, so I want you to do the same with the rest of these. You might have to then use it. But again, right here, 212, 420, make your table. Go to your graphing calculator and let that help you calculate these things. All right, give them a try, and then we'll go over them together. Have a great day.